Good morning, everybody. Today we are working on some of the limits, multiple choice questions and free response questions. So before we start, please subscribe my channel and leave a comment below that I subscribed. I will reply to you personally. Thank you so much. Let's start. For question 1 and 2, use the graph of function hx pictured below. So this is my graph h of x. Which of the following statement is or true about the graph of h of x? So we're going to go through 1, 2, and 3 and see which one, which statement is true. So let's start with that one. Number 1, limit x approaches -3 from the left, h of x is equal h -3. And this h -3 means this is my point, right? Which means it's a defined point. This is my x value and I don't know what my y value is going to be. So that y value and limit x approaches -3 from the left supposed to be exactly the same. Okay, let's try this portion first. X approaches -3 from the left. This is -3. Left of -3 is right there. This is left of -3. When I approach -3 from the left side, the graph is right there, that is approaching -3, right? So I'm going left -3 right there. The point is right here. What is the y value for that -3 from the left side? It's 1. So the answer for this is 1. Let's try h -3 point, like a defined point. Okay, defined point is a closed circle. So this is -3. And this is also 1 because this is a defined point. I'm not going to say -3 is equal to -4 because this is a hole. -3 can go arbitrarily close there. You can get 3.9999, but that will be limit. It's not a point. Point is only when you have these filled in circle. So this is also technically 1. So that statement is true. So when first statement is true, my choices are, excuse me, my choices are A, C, and D. So B doesn't have 1, D doesn't have 1. So these are my 3 choices. Let's go for statement 2. Limit x approaches positive infinity, h of x is -6. We can see that. This is positive infinity. When the graph x approaching positive infinity, you know, this is the graph that going towards positive infinity, right? So what is my y value there? The graph is going to continuously going in this direction. My horizontal asymptote is also going to go in this direction. You know, the graph is not crossing the horizontal asymptote, so my limit is -6. So here is -6. That's true. So now my choices are A and E because C doesn't have 2 and 2 is true. 3. X approaches -6 from the right. This is -6. When I going from the right, this is the right of -6. You know, the graph going towards or getting to the y value of -6 from the right side is, which one is that? It's this graph. This is the only one that is going from the right towards -6 y value, right? This one is going infinity something. That one is stopping at -4, but it's the x value is -3 for that one. But I'm talking about when I'm going right side of -6, this is the only graph that is not quite approaching -6 y value, but it's going in this direction, which means that's my positive infinity y value. Okay, so, but this one says it's negative infinity, so that's wrong. So my answer is 1 and 2, which means A. Okay, now let's check this question. Which of the following limit does not exist? Okay, they said does not exist. So let's try this one. Limit x approaches 7 h of x. This is 7 right there. And since they are talking about left and right both, then limit x approaches 7 from the right is going in this direction. Limit x approaches 7 from the left is going there. Both of them are going positive infinities. So it does not exist because infinity is not a real number. So that's true, right? It does not exist. Does not exist. Second, limit x approaches 0. This is 0. When I approach from the right towards 0, when I approach from the left to 0, the y value, the 0 is 2. But they said it does not exist. We are looking for, right? So this one exists, so that's wrong. Let's try this one. Limit x approaches -3 from the left and right. This is -3. When I'm going limit x approaches -3 from the right, I'm approaching -4. Limit x approaches -3 from the left, I'm going 1. So this is -4 and this is 1, which means does not exist, because in order for the limit to exist, it has to be limit from the left and limit from the right must be equal. Okay, so my answer is 1 in 3 in this case. 1 in 3, 1 in 3, E. Okay, let's try this question now. Now we have, which of the following statement is true? This is a g of x function and it's a piecewise function. And look at the restrictions. Always check the restrictions. X less equal -2. Less means always left. X greater -2. You know the alligator mouth open towards x, which means the x is greater. So x greater than -2, which means that's right. Greater goes right, less goes left. Okay, so these are my two pieces. Now let's read this, which statements are true. G -2 is undefined. -2, this means they are talking about a point. Like if the x value is -2, then what is the y value? Do we have even a y value there, or it's undefined? Undefined when you have a 0 in the bottom, okay? But that's a number over 0. Let's plug in -2. But where should we plug in -2? In this piece or that piece? Since I'm plugging in -2, like equal, x is equal -2, then I have to pick this, okay? Because this one says x less in equal -2. This one doesn't say equal. So I'm gonna pick this function and plug in -2. So let's see, e -2, -2 plus 1. I plugged in everywhere, replacing everywhere x with -2. So this one is going to give me -1, e -2. Negative x are not acceptable, so I'm going to change that to 1 over e2 so I can make it positive, and that negative stays up here. You know it's not undefined because I'm not getting 0 in the bottom. E is like a pi, it's 2.7 something something. So it's a number, okay? So it's not undefined. So this statement is wrong because they said it's undefined, but it's not. Let's try that one. Limit x approaches -2 from the left of g of x is equal to -1 over e squared. And that's exactly what we got when we plugged in -2. And from the left means I'm gonna pick this piece of the information, right? That's left. I plugged in, I got -1 over e squared because in the limit questions, the first thing is plug in. So that's true. Let's try this. Limit x approaches -2, g of x does not exist. I don't know, we have to check for -2 left and right. So we already have a left right there, which is -1 over e squared. But let's try the right. Right is this one. So if I plug in a cosine for the x, I plug in -2 pi, you know I'm not getting 1 over e squared. That's for sure. I don't have to solve it, but I know that I'm not getting this. So if the left in the right limits are not the same, like not exactly the same y values, then it means limit does not exist. So then this one is also true. So number 3 is 2 and 3, which is C. Okay, this one is talking about find the limit x approaches pi over 6 sine 2x and 3x. If you guys pay attention, again, for limit questions, the first thing first, plug in. So I'm going to go direct substitution, sine 2 pi over 6 over 3 pi over 6. I'm going to simplify that, okay? So I'm getting sine pi over 3 because we simplify that, okay? And we simplify this, so I'm going to get pi over 2. Now we have to check sine pi over 3 on the unit circle and see what is pi over 3 sine. You know sine means y values as an order pair in the unit circle. So here's the unit circle. This is pi over 3, that's x, that's y. So sine y means, sine means y, and sine pi over 3 is square root 3 over 2. Okay, so square root 3 over 2, I'm going to plug in that value, square root 3 over 2. And in the bottom, I have pi over 2. Now we have to fix this because you know this is reciprocal when you change this division into multiplication. So I'm going to use reciprocal and see what we get. 3 over 2 times, this change into times, 2 over pi. You just do the reciprocal for the denominator. They cancel out. I'm left with pi, square root 3 over pi. Square root 3 over pi. A, that's my answer. Question number 5. Limit question again. The first thing first, plug in. So I'm going to plug in 3 here. And I'm going to plug it in here so I can do my questions there. 3 plus 1 square root plus 2 over 3 minus 3. So I got 4. 4 is a perfect square. 2. Oh, that's a minus, sorry. 2 minus 2, 3 minus 3 will give me 0 over 0. We need more work. What is more work? Conjugate if you have a square root. Least common denominator, factors, common factor, distributive property. So since I have a square root, I'm going to do conjugate. So times, conjugate means this sign you change to positive. Inside the square root you don't touch. So I have x plus 1 square root plus 2. The same thing, x plus 1 plus 2. Now we have to do the distributive property between them. Okay, straight across multiply. So these two multiply, square root x plus 1, square root x plus 1, you times. So you will get x plus 1 because square, it means something like this, x plus 1 square, like both of them, right? So they cancel out, I'm left with x plus 1. Now you are going to multiply x plus 1 with plus 2. So when I multiply, I'm getting plus 2x plus 1 squared. Now I'm going to multiply negative 2 and that, which is going to give me negative 2x plus 1. Then I'm going to multiply negative 2 and positive 2, which will give me 4, right? So I'm done so far. And bottom in calculus, don't touch the bottom, guys. It has to stay exactly the same way. So plus 1 plus 2. Most of the time we do not touch the denominator. Don't multiply, add, subtract, something. If it's simple, we will do it, but it's something like that, leave it alone, because you don't have time on the AP test to do all that stuff. So they cancel out. I'm left with x minus 3 because negative 1 plus 1, and then I have x minus 3 in the bottom, and I have x plus 1 square root plus 2 again. They cancel out. I'm left with 1 over x plus 1 plus 2. Now limit x approaches 3, plug in 1 over 2 plus 2, because 3 plus 1 is 4, square root 4 is 2, and I'm getting 1/4. The answer is B. Question number 6. In which of the graphs below is FC defined? Define means, again, I'm going to say define means closed circle, like you have actually a point. When you plug in C, you get Y, exact Y value, okay? And this one is a limit x approaches C, f of x exist. In order for f of x to exist, a limit exist, limit x approaches C from the left, limit x approaches C from the right. It has should have exactly the same Y value. In this case, they said the limit and the defined point are not equal to each other. Okay, so let's try. First of all, let's find the defined point, and that's exactly how I do, because it makes it quicker and easier and less mistakes. So let's find defined point. Do you see that's a hole for the C? CY value is not a because it's a whole, so that one is out of question. Try this. C is x value, the y value is a, and it's a closed circle, it's a defined point. Perfect. C, that's a C, and both of them are wholes. Like if I say C, when I plug in C, I'm getting a as a y value. No, because that's a whole. I'm not getting b because it's a whole, so out of question. This one, when I plug in C, I'm getting a point B. I'm not going to say I'm going to get point A, but because that's a whole and that's a defined point, so that's true. Again, C has a defined point B too. Okay, so my choices are B, E, B, D, E. Now let's go for the limit. X approaches C exist. So I'm going to go here first. Limit x approaches C from the right. Limit x approaches C from the left is equal a. Yeah, that exists. X approaches C of f of x is equal a. Okay, good. Now try this. Limit x approaches C from the right. Limit x approaches C from the left is not exactly y value, but we're going to pick arbitrarily close to a. So when you round it up, it's going to be a anyway. Limit x approaches, it's limit, it's not point, okay? Please make sure you remember this. Whole is not a defined point, but we can have a limit there, because in the limits we always pick arbitrarily close if it's a whole. So limit x approaches C, f of x is equal a when we round it up. In this case, limit x approaches C from the left. Limit x approaches C from the right. You see, x approaches C from the left is A. Limit x approaches C from the right is B. So limit does not exist here. So that is out of question now, because they said limit exists. My choice is B and D. Now let's see, they said the limit and the point are not supposed to be equal. So you know this is f of C equal A, right? And since they said it's not supposed to be equal, like I should have different y values, and they are exactly the same, so that's not my choice. So I know I'm left with D, but I will show you f of C is equal B. You say limit is A, but the defined point for the C is B. That's what they said, it's not equal. The limit and the point are not equal, and they are not. So that's D. Question number 7. Given above is the graph of the function f of x, the value of limit x approaches 2. This means left and right both. Square root 3 f of x is what? So I can apply properties, and if you don't want to apply the property, you still will get the same answer. 3 is going to stay as a 3, that's a coefficient. So I'm going to say limit x approaches 2, square root 3 stays. And what is limit x approaches 2 of f of x? Now that's 2. Limit x approaches 2 from the right. Limit x approaches 2 from the left. I'm going to pick arbitrarily close. This is a point, okay? It's not limit. This is limit. So limit always with the graph. Arbitrarily close, you round it up, it's going to be 2. And it goes under the square root, of course. So that's going to give me 6. My answer is B. Okay. Consider, these are free response questions. Now you have to be very careful in paying attention right now. Consider the function below to answer the following questions. Always read the instructions. F of x is my piecewise function. These are my restrictions. And when I see the piecewise function, I always say, and it's a limit question, like technically, and I would say x less than -2. Less means left. X greater than -2, which means right. And since you have a paper test, AP test, then you can write on your question like on top of it. So you always do that, okay? That's g of x function. Number 1, A, find the value of limit x approaches -2 from the left f of x and show your work. So I am going to show the work and I will get this. So let's see, limit x approaches -2 from the left. You know left is this portion because x less than -2. So I'm going to plug in -2 in this portion of the question. So I have -2 squared plus 2 absolute -2. It's going to give me 4 plus 2 When I take it out, -2 from the absolute, it's going to turn positive, equal 8. And this question has 1 point. Okay, so you technically got 1 point here if you do the work and you show them and box the answer always. Okay, let's go to part B. Part B is, in order for limit x approaches -2 f of x to exist, what two limits must be equal? So in order for it to exist, what two limits? Of course, limit from the left and limit from the right supposed to exist, right? So I have to, do you see I'm reading a question, half of the question, and I'm answering this first, then I'll go for the rest. Always do that. So I'm going to say limit x approaches -2 from the left of f of x, and please take words from the question, like exactly from the question. Okay, so I'm going to say limit x approaches -2 from the left. This is what I'm doing, the two limits part, must be equal to limit x approaches -2 from the right of f of x in order for limit x approaches to -2 from the left and right of f of x to exist. Okay, so f of x, in order for limit x approaches -2 f of x to exist. So that's this part of the question. Let's see, find the values of a for which this limit exists. Find the value of a for which this limit exists. So, and again, show your work. Now, if you check, this is my a, right? Always, 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 when you are looking for any variable missing in the piecewise function, make these two pieces equal each other. For the x, you're going to plug in obviously -2, and then you solve. Since this is like a limit question, that I have to like show my work as a limit, like limit x approaches -2 from the left of f of x is equal limit x approaches -2 from the right of f of x, right? Like this. Now you go ahead and plug in. So I'm going to plug in -2 from the left, which we already got 8, so I don't have to do this again. When you have like different parts of the question and you already answered one part and you need that one part in another part B like this, then you don't have to redo all this stuff. You just plug in because you already did the work. Then this one's -2 from the right is that one, right? So I'm going to write 3x is -2 plus a. Now you solve this, it's going to give you 8 equal -6 plus a, and it's going to give me a equal 14, and you box your answer. Now this part has 2 points, and you can tell what do I mean by 2 points. Oh, so I have this and I have that. So total you got 3 points so far. Okay, let's go part C. Find the value of limit x approaches g of x. Okay, question mark. This is first portion, and I am going to answer the first portion first. Okay, so my g of x function is up here. That is 2x squared minus 5x minus 3. 2x squared minus 5x minus 3. In the bottom, it's x squared minus 9, I think. Yes. So this is my g of x function, and since they said find the limit x approaches 3, you know direct substitution goes first. So I'm going to do direct substitution. I have 3 squared minus 5x, 5, not x. I'm going to go 3 minus 3 over 3 squared minus 9. This is going to give me 0 over 0. You do it, you're going to get 0 over 0. If I get 0 over 0, which means I need more work, right? What is more work? Since it's a quadratic function, then I have to factor. Least common denominator, conjugate. I don't have square root, so no conjugate. Common factor, all that stuff. So since it's a quadratic, obviously I have to do my factor. So limit x approaches 3, g of x is equal factor. How do we factor, guys? If you don't know or you forgot how to factor, make sure that you watch Algebra 2 videos. Go to the playlist, my channel playlist, and then there will be Algebra 2, and you can find quadratic equations there. Okay, in this case, what do we factor? I have to find the factor of 2x. So that's 2x and 1x. The factor of 2 is 2 times 1 is 2. The factor of 3 is 3 times 1. So these are my factors, and we're going to pick 3 and 2 to make this 5. You add them, you get 5, or you subtract and you get 5. So in this case, I'm adding. So let's try this. 2x, I'm getting plus 1, right? 2x plus 1, and I'm getting x minus 3. Since you know negative 3 times 1 is negative 3, and positive 2 times positive 1 is going to give me positive 2x squared. So this is what I got. Okay. You will be asking how do I know plus 1 goes with 2x and negative 3 goes with x? I don't. I can try 2x minus 3 and 2x minus 3 and x plus 1. You can do the FOIL like this, right? You can do the foiling and see if you are getting back this answer. And it's not taking that long. You can, do it in your head very quickly. But if you're not getting this, then you switch around your 3 and 1. And that's exactly what I did. Then for x squared minus 9, when you factor out that, if you have a minus, you know this is x minus 3, like my factors. But if you have minus, 1 is positive and 1 is going to be negative. But if it's positive, then both positives. So that's x plus 3, x minus 3. X minus 3, x minus 3 cancel out. I'm left with 2x plus 1 and x plus 3. Now I'm going to plug in my x approaches 3 for the limit. So 2 times 3 plus 1 over 3 plus 3, which is going to give me 7 over 6. So limit x approaches 3 for g of x is 7/6. So I answered this part of the question already. Now let's do is g3 and limit x approaches 3 g of x is equal. You know, g3 means you have a point, right? So when you plug in 3 directly in g function, are you getting whatever you're getting from here is exactly the same like 7/6? No, because we already plugged in g3. Do you see? We did this for the limit, but we know it's going to be the same thing when I plug in, so it's going to be 0. So no, I don't have to do this again. I know limit x approaches 3 g of x is not equal g3. Why not? This is the explanation you have. Okay, so this is the graph question that you have. They said limit x approaches when you have infinities. This means you are doing asymptotes. So limit x approaches -2 from the left. This is -2. If I'm going from the left, they said you're going to positive infinity like this. So it means I have a vertical asymptote that it's not supposed to cross, right, at -2. -2 from the right. If I have -2 from the right, like I'm going -2 in this direction, then it's going to go down there, which is going to negative infinity from the right. Limit x approaches 2 is 3. So this is 2, and they said the limit is 3 up here. So this is the way I'm doing it. You can make your own graph, doesn't matter. Okay, like that. And I can erase this portion right there, like right here. Oh, it's gonna go right there. Okay, so that's there. That when I approach 2 from the left, right, and from the left, I'm getting 3. Limit x approaches negative infinity is 0. This is x approaches negative infinity. This is going negative infinity. So they said the limit is 0 because 0 is your horizontal asymptote. It's not going to cross the horizontal asymptote 0. H2 is -4. That's a point. Like this is a point, defined point. Okay, so if you guys have any questions, please comment below and I will help you out. If you didn't understand anything in this worksheet, then ask me and I will redo that portion for you guys. Thank you and have a good day.